Hello everyone, my name is Brandon3055 and in this video I'm going to be showing you how to use the new Draconic Reactor in Draconic Evolution. Now to get started, we're going to need one Draconic Reactor core, 4 reactor stabilizers, and at least one reactor energy injector. I'm going to just build up a couple of blocks in the center here, place down the core, then 4 blocks out on each side. 1, 2, 3, 4. I'll build up to the same level and place a reactor stabilizer. Then I will place a reactor energy injector directly underneath the core. This could also go above the core, like so. First thing you'll notice, this is not the same as that one over there. That one is set up in a vertical configuration. You can build it either way. Now before we can go any further, this will need a substantial amount of power to get it started, as well as a decent sized energy buffer once it's running. So the obvious solution for that would be the Draconic Energy Core. So I've just quickly built a standard tier 5 energy core and charged it up to about 7 billion RF, which should be plenty of power to get this started. Now quick note about the stabilizer placement. I would recommend at least 4 blocks distance between the stabilizers and the core for the maximum size reactor. If they are too close, you will potentially run into issues when the reactor heats up and expands. You can put these up to 10 blocks away, which includes the energy injector. Now, if you have the setup right and you right click on one of these, you should see the GUI open and the status will be offline. If however the status shows as invalid setup, or you can't actually access the GUI, like for example this one, if you right click it nothing happens, probably because when you built the set structure, one or more of the reactor stabilizers is blocked by some object. Now I removed that, but the structure will still show as invalid setup. To fix this, you either need to break and replace the invalid stabilizer, or the easiest option is to simply place the block here, break the core and replace it. That will automatically update all 4 stabilizers and the system should show as offline. Now the way this reactor works is a little bit complicated, but I'll try to explain it to the best of my abilities, and if you get lost, you can always go to the information tablet for more information. So in the GUI there are 4 meters you need to be concerned about. There is the core temperature, the containment field strength, the energy saturation, and fuel conversion level. The temperature is simply the temperature of the reactor. As this increases, the load on the containment field will also increase. If this passes 8,000 degrees, which is shown by these 2 red marks here, the drain on the containment field will increase exponentially. So it's ideal to keep the temperature below 8,000 degrees for optimal efficiency. The containment field is powered by the energy injector. The more power you pump into the energy injector, the stronger the containment field will get. It's not possible to get the containment field to 100% because the containment field will accept an infinite amount of power. So ideally you want to keep it around 50% or at least out of the red. If the containment field drops to 0, the reactor will lose containment and explode. The energy saturation is basically just an energy buffer within the reactor. As this buffer drains through the extraction of energy via the stabilizers, each one of these is an energy output. This buffer will go down. As this buffer goes down, the energy generated by the reactor will increase to compensate. But you do not want to drain too much energy out of this because the lower this gets and the more the reaction increases, the higher the temperature will go, and therefore the more drain there will be on the containment field. At a certain point, it will become very inefficient and possibly overload and explode. You don't want that. The fuel conversion level shows how much of the fuel, awakened draconium, has been converted into chaos. Chaos is the new element which can be found on the Chaos Islands and is required to build the reactor. But that's a story for a different video. So the reactor will accept up to 8 blocks of awakened draconium. That is 10,368 millibuckets. That is what that measurement means. There is also a stats page in the GUI which shows you the temperature load factor. This is basically just how much energy is being drained from the containment field. When the reactor is shut down, this is 0. During normal operation, under 8,000 degrees, this will be 1. If you go above 8,000 degrees, this will start increasing exponentially, showing that the draw on the containment field is increasing exponentially. Core mass, that is just the amount of fuel in the reactor. That's 8 meters squared, because, no, 8 meters cubed, sorry, because there's obviously 8 cubic meters of draconium in the reactor. Generation rate, pretty self-explanatory. Field drain rate, also self-explanatory, that is how much power is being drained from the containment field per tick. And fuel conversion rate, how fast you are going through your fuel. You'll notice that's in nanobuckets per tick, not millibuckets, because this reactor goes through fuel very slowly. So 8 blocks of draconium will last a really long time. Now, before I actually start up the reactor, I'm just going to show you how the energy conduit is hooked up. So, what we have here is the energy core, obviously. This has enough energy in it, hopefully, to get the reactor started, because in order to start the reactor, you need to supply it enough energy via the energy injector to heat it up, get the containment field up to 50%, and get the energy saturation up to 50%. At that point, you will be able to start the reactor. So, to get energy to the injector, you obviously don't want to just connect this directly to the injector, because, as I said earlier, the containment field will accept an infinite amount of energy, so that would just drain your entire energy core pretty much instantly. You don't want that. You don't need that much energy. So, that is why I added this block. This is called a flux gate, or a flow gate. This is the flux version. This allows you to control the amount of RF flowing through this device. I have it set up here controlled by redstone via this comparator, which is connected to the energy injector. This is currently set to comparator mode. We want containment field inverted. So this will output a value depending on the charge in the containment field. So when the containment field is 0, it will be outputting 15 because I've set it to the inverted setting. And basically, the more energy that is pumped into this, I will have to. You can see more information about this flow control in the information tablet. But basically, at 15, you will be getting 200 RF per tick through this block. At 0, you will be getting 0. And anywhere in between will just be between. So the current value is 173,000 RF per tick. As this redstone signal increases, it's currently at maximum, that would go up. But it's not at 200 because there's obviously some loss through these two redstone lines, which I can just replace with comparators to get that up to 200. As the field strength increases, the signal will drop and the amount of energy being supplied will go down. That is just an easy way to regulate the field strength. Both of these blocks, including these, because the comparator can be hooked up to either the energy injector or the stabilizer, have support for both Open Computers and Computercraft. So you could build a Computercraft or Open Computers Lua program to control this reactor. And with that, obviously, you could get a bit more precise control than a simple analog repeater setup. Okay, so that's the power input side. Over here is the output side, which is a bit simpler. So simply have power coming out, going through a flow gate, and back into the core. It's important to have a flow gate here, obviously, because there is no limitation to how much the reactor will put out. And as I said earlier, you do not want to drain the energy saturation beyond a certain point, or bad things will happen. So I have this set to 100,000 RF per tick, although this reactor should be safe up to around 3 to 500, depending on how far you want to push it, but for this demonstration, 100 will be fine and safe. In order to start the reactor, you want to just press charge reactor, and that will start draining energy from the energy core and charging the reactor. Now, to make this go a little bit faster, I'm just going to bypass this flow gate. And that's pretty much instant. But before you actually press start, make sure you break this or it will pretty much instantly explode. You don't want that. But now that the reactor is charged, we can press activate, and the reactor is now generating power. You can see it's currently generating 200 and, well, that's going down because the saturation is going up, but over 200,000 RF per tick. The field drain rate is going down because the temperature is actually, okay, temperature is going up, but the energy saturation is also going up, and energy saturation also has an effect on the containment field strength. So the containment field drain is going down. You can also see the fuel conversion rate is dropping from where it was originally because the energy saturation is going up, and the reactor is now running. I can increase the energy drain from the reactor a bit, and the saturation will continue to rise. Okay, I've done something wrong here. Oh, okay, I have installed this flow gate backwards. Whoops. Okay. Now the energy saturation is dropping. At a certain point the containment field will start to drop. There it goes. And I have this set to a fairly, oh no, it's not that high. That should be right, but this will settle when the generation rate reaches what I have that set to. If you set that too high, obviously this will drop too low and you will have issues. Now, when this settles, if the containment field is at least 50% or higher, you may want to adjust this circuit to reduce the containment field value so you're not wasting so much energy, because this is currently sending 100,000 RF almost back into the containment field. So I could just drop this value a bit, and you'll see that just went up a bit as the redstone signal increased. Now, some of you may have already seen this if you've watched my video about what not to do with the Draconic Reactor, but what I'm basically doing here is I have a reactor set up, and the containment field is just being powered by some creative energy cells. And what I'm going to do now is what you should never do if you don't want something bad to happen, and that is I'm going to connect the output from one of the stabilizers directly to the energy injector. So there will then be infinite power coming out of the energy saturation bar, going directly into the energy injector. This will instantly drop the energy saturation to 0, which will instantly increase the temperature up to past 8,000, and well, it'll just keep going up really quickly. So the containment field will start to drain really quickly, overwhelm these creative energy cells, and the whole thing will just blow up. And it will only take a few seconds. So, sorry cow. And boom. I may need to tweak the explosion resistance of these stabilizers. But there we have it, a big boom. And the size of the explosion is dependent on the amount of fuel in the reactor. So for example, if you only have, say, 1 ingot of draconium in there, it will only be a 20 block radius, whereas the full-size reactor is a 200 block radius. And the explosion is still going. A little bit laggy, but not as laggy as some. But there you have it. That is the Draconic Reactor. Thank you for watching. I hope you enjoyed this video.